Hello dear students. Today we will discuss properties of Laplace transform of first shifting theorem. So this is the lecture number 4 of integral transform. So what is the first shifting theorem? The theorem of first shifting theorem is if L of ft equal to fs, then L of e to the power at ft equal to f of s minus a. This is the statement of first shifting theorem of the Laplace transform. Now proof is very simple. Let L of ft equal to fs 0 to infinity e to the power minus st ft dt. This is the definition of the Laplace transform. Then we have to evaluate the Laplace transform of e to the power at ft. Then L of e to the power at ft becomes 0 to infinity e to the power minus st into e to the power at ft dt. In place of ft, ft becomes e to the power at ft dt. On simplification, it becomes 0 to infinity e to the power minus of s minus a of t ft dt. Then the integration becomes 0 to infinity e to the power minus ut ft dt, means where u equal to s minus a. S minus a is greater than 0. So this function becomes f of u integration of 0 to infinity e to the power minus ut ft dt becomes the function of the form f of u, and where u is s minus a, so it becomes f of s minus a. So this is the result of first shifting theorem of the Laplace transform. Hence L of e to the power at ft equal to f of s minus a. So this is the proof of the first shifting theorem of the Laplace transform. Now take example related to the first shifting theorem. Here is example. Find L of e to the power minus t 3 of sine hyperbolic 2t minus 5 of cos hyperbolic 2t. As we know that L of ft equal to fs, then L of e to the power at ft equal to f of s minus a. This is the first shifting theorem of the Laplace transform. Also L of sine hyperbolic at is 2 divided by s square minus a square, and Laplace of cos hyperbolic 2t becomes s divided by s square minus a square. Now therefore L of e to the power minus t 3 of sine hyperbolic 2t minus 5 of cos hyperbolic 2t can be written as 3 as it is, and Laplace of e to the power minus t sine hyperbolic 2t becomes 2 divided by s plus 1 of whole square minus 2 squared. Means that here the power of e to the power minus t means the value of a is minus 1, so it becomes s plus 1 of whole square minus 2 of squared. Then after minus 5 as it is into here the coefficient e to the power minus t, so s plus 1 divided by s plus 1 of whole squared minus 2 squared. That means we have just transformed the parameter s becomes here s plus 1 of whole square, and here s plus 1 of whole square. After simplification it becomes 1 plus 5s divided by s square minus 2s minus 3. So this is the first shifting theorem related to the first shifting theorem result. Thank you.